Okay, let's unpack this then. Welcome back to the deep dive. This is where we take your sources, dig in, and find the core insights. Today we're doing a deep dive into this diagram you shared, the one titled Azure Databricks at 360.
Ah, yes, that one. It's a really useful overview, isn't it?
It really is. Think of it as like a blueprint for this big cloud platform for data science, data engineering work.
Mm-hmm.
So our mission here is to go, beyond just seeing the boxes and lines. We want to really get what the key components are, why they fit together like this, and what it means for, well, actually getting data work done efficiently.
Exactly. And what's really interesting, I think, is how this diagram visually pulls together all those different layers you need. From where you're actually writing your code
Mm.
to where the number crunching happens and where the data itself actually lives.
Right.
It shows this cohesive environment. It's really designed to make collaboration and putting things into production just easier.
Absolutely. So looking at this blueprint, I mean, where do we even start? It kind of feels like everything circles back to the data itself and how you actually interact with it.
That's a good way to put it, yeah. The diagram points right to data sources. Things like DBFS, that's the Databricks file system, and also the familiar stuff like Azure Blob storage. That's where your raw material is sitting.
Okay.
Pretty much all your work in Databricks is, well, it's about connecting to that data.
And the main place you do that work, sort of interactively, that seems to be the workspace, right? The diagram shows that structure with like shared folders for teams and then user folders for your own stuff.
Yes, exactly. The workspace is your central hub. It's where you organize all these things it calls workspace assets. And the diagram lists them out pretty clearly. You've got notebooks, clusters, jobs, libraries, data, and experiments. It's all designed to keep your project stuff together.
Gotcha. And notebooks seem really central to that interactive exploration piece the diagram shows. Running code bit by bit, mixing Python or SQL, maybe using %QL for that, adding text explanations.
That's where you figure out the logic, visualize things.
Right. You build your logic there in a notebook. But then to actually run it, especially at scale, you need the compute power. And that's where clusters come in. The diagram shows them clearly made up of a driver node and worker nodes, basically the brains and the muscle.
Yeah, okay. And this is where the diagram gets, well, pretty detailed and interesting. It shows you can create new clusters, manage the ones you have, you specify the Databricks runtime version, language versions, and crucially, the type of cluster. It lists general purpose, storage optimized, memory optimized. What's the thinking there? Why the different types?
Well, choosing the right cluster type, it's not just some minor setting. It's actually critical for how well things run and how much it costs. So, for instance, a storage-optimized cluster is going to be best for jobs that are reading and writing massive amounts of data back and forth.
Okay.
Whereas a memory-optimized one, that's better for workloads that need to keep a lot of data right there in RAM. Think like complex joins or maybe training machine learning models.
Right. Picking the wrong type. That can really mean wasted time, wasted money.
That makes a lot of sense. So you're tailoring the engine to the specific job. And I also noticed that auto termination detail right there on the clusters section, it says it can shut down after, N minutes of inactivity? How important is that feature?
Oh, it's incredibly important, especially, in the cloud where you pay for what you use. Forgetting about an idle cluster, that's the common way people end up with surprise cloud bills.
Yeah, I can imagine.
So auto-termination is like a built-in safety net for costs. The diagram highlights it because it pushes you towards being efficient.
Okay, so you explore notebooks, running on these clusters within your workspace, pulling in your data. What happens when you need to make that work, repeatable? Or run it automatically? The diagram points to Databricks jobs then.
Exactly right. A job is basically how you operationalize your work. You take a task, often that's a notebook you developed, or maybe a package application like a JAR file.
A JAR file.
Yeah, like a compiled bit of code, often used for Spark jobs. You link that task up with a schedule. The diagram shows you can schedule things from like every minute up to monthly.
Oh, yeah, okay.
This is how your analysis, your data processing, goes from you running it by hand to being a reliable automated pipeline.
Got it. So you develop interactively workspace, notebooks, libraries, connect to data, run it on configured clusters, and then schedule it all using jobs. It really paints a picture of how these pieces connect to cover that whole data lifecycle from just poking around to full production.
Yeah, and the key thing to see, I think, is that it's not just a random collection of tools. It's designed as a unified environment. You see the UI, the CLI, command line, and the REST API mentioned and as ways to interact. Those are just different ways to control and orchestrate all these components we just talked about.
Okay. So, pulling it all together, what does this really mean? This diagram, Azure Databricks at 360, it gives you this landscape view. You see the essential parts, the workspace organizing things, notebooks for the dev work, clusters for the power, jobs for automation, and how it all plugs into your data sources.
Right.
Understanding why each piece is there and how they relate, that feels like the real shortcut here. It's not just a feature list, it's about the workflow they enable together.
Well said.
Which, brings up an interesting question. We saw the specifics in the diagram, things like specialized cluster types and that mandatory auto-termination setting based on inactivity. So how might really consciously planning your cluster strategy around those specific details, not just taking the defaults, how might that fundamentally change, say, your total cost of ownership, or even just how fast your data team can move?
Hmm.
Something to definitely think about as you start mapping your own work onto a platform like this.